Good evening. It is Matt Rogers. It is now the 13th of December 2024. On this broadcast, we're going to speak about exoplanets in the universe. Nearby exoplanet has grown a tail 44 times longer than Earth, and it's acting like a giant stellar windsock. The researchers have detected a giant tail of gas leaking from an exoplanet near Earth. The giant structure, which is up to 350,000 miles long, is being blown away from the alien world by stellar gusts, allowing researchers to use it like a windsock. An alien world near Earth is being trailed by a gigantic tail stretching longer than 40 Earths as it closely circles its home star. The enormous structure, which is made up of gas leaking from the exoplanet's atmosphere, is being blown away by stellar winds like a giant windsock, these experts are explaining. Close to our solar system, the exoplanet WASP-69b is a gas giant. It's around the same size as Jupiter, but less than a third as a mass of the orbits a mainstream sequel star, roughly 160 light years from the Earth. It is very close to its star, completing a single round trip, the alien sun, every 3.9 days. Since its discovery in 2014, researchers have noticed that WASP-69b is losing up to 200,000 tons, that is 180 metric tons, of mostly helium and some hydrogen gas per second, which is likely being lost as a result of it being superheated by the exoplanet star. At that rate, the exoplanet has likely lost up to 7 Earth masses during their lifetime, which is and has lasted around 7 billion years. Scientists previously speculated that WASP-69 might be a comet-like tail made up of some of the gas it leaks into space, but this has never been confirmed. However, a study published on the 9th of January in the journal Astronomy and Astrophysics, researchers analysed the alien world using data from the WM Keck Observatory in Hawaii, previously measuring the planet and its surroundings, and found that it really did have a tail that stretches up to 350,000 miles, that is 560,000 kilometers long, roughly 44 times as long as Earth in its width. This heavenly exoplanet, WASP-69b, the tail forms when the stellar wind blows and the leaking gas away from the exoplanet, creating a tail in its wake. Stellar winds, similar to the sun's solar wind, in its stream of charged particles that are constantly being spat out by the star. If the stellar wind were to disappear, then the tail would also fade away. They also explain the stellar wind. If it was down to Tampa, then you could imagine the exoplanet is still losing some atmosphere. But it's just the shape into the tail that these scientists explain in a statement publicized in December the 10th of this month, 2024. Without the stellar wind, the gas escapes on all sides of the planet, which would be spherical. But if you crank up the stellar wind, the atmosphere then gets into a formation shape, into a shape of a tail. They also explain as well, the discovery could help us learn more how the gas giants form and evolve over time, and also provide scientists with a great opportunity to measure the stellar winds of a distant star by using a tail like a giant windsock. These representatives wrote this in the statement. These comet-like tails are really valuable because of the form when they are escaping the atmosphere of the planet, runs into the stellar wind, which causes the gas to sweep back. Observing such an extended tail allows us to study these interactions in great detail. More news about exoplanets. A baby exoplanet, equivalent to a 2-week-old infant, is the youngest alien world ever spotted, and it's orbiting a wonky star. A new study has identified an exoplanet that is just 3 million years old, around 1.5 thousand times younger than the Earth. Along this misaligned protoplanetary disk, that researchers can't explain. A baby exoplanet recently spotted relatively near Earth and its youngest alien world ever seen. A new study suggests researchers say the rare sighting is linked to the mysterious wonky object disk around the exoplanet host star. This newly discovered exoplanet, known as IRAS 04125 2902b or TIDE 1b, as a lightweight gas giant with a diameter slightly smaller than Jupiter's, but around 0.4 times the mass of the solar system's largest planet. It orbits a protostar, a baby star still growing to its final size, located in the Taurus cloud, around 520 light-years from Earth, completes one rotation around the protostar every 8.8 days. Based on the age of the protostar, which currently has a mass around 70% of our Sun, this baby exoplanet can only be up to 3 million years old, around 1.5 thousand times younger than the Earth. If you were to compare the exoplanet's current age to a human lifespan, it would be about 2 weeks old baby. The researchers have described the baby exoplanet in the study published November the 20th in the journal Nature. The exoplanet was first spotted in the data collection by NASA, transmitting exoplanet survey satellite TESS is continuously passing in front of the host star. Discovering planets like this one allows us to look back in time, catching glimpses of planetary formations. It helps us to explore our place in the universe, where we came from and where we might be going. Exoplanets are normally only visible when they are more than 10 million years old, because until then they are obscured from the sight of protoplanetary disks, the swirl rings of dust, gas, and other planetary building blocks. In with the exoplanets form, but even then, only around a dozen exoplanets have been found that are less than 40 million years old. Planets typically form of a flat disk of dust and gas, which is why planets in our solar system are aligned in pancake flat arrangements. But here, the disk is tilted, misaligned, with both the planet and its star. Surprising twist that challenges our current understanding of how planets form. The disk is believed to be misaligned relative to the star by around 60 degrees. Researchers are not sure why the disk is misaligned and why this exoplanet B1 is not located within the disk. One possible explanation is that the disk has been pulled out by the companion star, which orbits the protostar at a distance around 635 astronomical units, 635 times the distance between the Earth and the Sun. However, this may be likely given how far away the companion star is. When you think about it, folks, the discovery helps to fill in gaps about different worlds and indeed how they form. For example, exoplanets form through our universe. Experts believe that it took between 10 million and 20 million years for Earth to fully form, whilst it seemingly takes less time for a gas giant like these exoplanets to form, but there is still more to learn. These scientific researchers are planning to conduct follow-up studies on this juvenile world to assess if it's still accelerating material from the disk. However, the atmosphere compares the surrounding disk's material, in which it's losing its upper atmosphere due to the inflation and also substantial effects of its host star. Folks, a new study's come out as well. The unique extreme James Webb Telescope detects possible alien worlds bubbling over the volcanoes. Astronomers using the James Webb Telescope have detected possible signs of gas release from volcanic activity on a distant exoplanet. These bunch of scientific researchers explain, today we know more than 5,000 exoplanets, planets outside our solar system that orbit other stars. While the efforts to discover new worlds are going on, we steadily learning more about exoplanets that we've already detected, their sizes, what they're made of, and whether they have atmospheres. The scientists have now provided the evidence for sulfur-rich atmospheric on the world of this 1.5 times the size of Earth, located 37,000 light-years away. It's confirmed it will be the smallest known exoplanets with an atmosphere that is potential presence of the gases sulfur dioxide, hydrogen, sulfide in the atmosphere, hint of molten or volcanic surface. Think about this, folks. In our solar system, we have two distant categories of planets, the small rocky ones, including Earth, Mars, and the gas giant, such as Jupiter and Saturn. However, exoplanets span a great spectrum of size. Our solar system lacks a planet size, falls into the range between Earth and Neptune, but it turns out that the most common type of planet we have seen around other stars in our galaxy. The ones closer to Neptune size are called sub-Neptunes, and the ones closer to Earth size are called super-Earths. These exoplanets are super-Earths, slightly bigger and heavier than Earth. With the calculations of the atmospheres of these planets, it is still an open question, one that is only starting to explore with the James Webb Space Telescope, launched in 2021. Other exoplanets were discovered in 2019 with NASA's TESS Space Telescope. Most exoplanets, including other objects, have been detected by using transit method. These measurements are tiny dips in starlight, with the planets passing in front of the star. This dip is more observable for larger planets, enables us to figure out the size of a planet. Even the James Webb Telescope can separate tiny planets from their host stars as they orbit their stars too closely. But there is a way to see the planet's atmosphere from the entangled light. When a planet passes in front of a star, some of the starlight filters through the planet's atmosphere, hitting the gas molecules and atoms present there on its way to us, also pointing towards on Earth. Every gas modifies the light of its own signature manner. From the light we receive from the Earth star system, we can infer with the inspections of that atmosphere, and also where we can see the scientific researches. This is called transmission, a proven technique that has previously been seen to confirm the presence of CO2 in exoplanets' atmospheric temperatures. This discovery was surprising as it stands out the stark contrast to the atmospheres of rocky planets in our solar system. Whereas water vapor and carbon dioxide are much more relevant, Earth's atmosphere, for example, is rich in nitrogen, oxygen, and traces amounts of water vapor. Meanwhile, Venus has a thick atmosphere dominated by carbon dioxide. Even Mars has a thin atmosphere dominated by carbon dioxide. Additional observations will be necessary to confirm the presence of gases. The James Webb Telescope observations has previously spotted signs of SO on an exoplanet, but this was a gas giant, not potentially rocky world such as other known exoplanets. The potential presence of SO and HS raises questions about the origin. One explosive possibility of volcanic formations driven by tidal heating, much like what is observed on Jupiter's moon 2. The gravitational pull of the host star on this planet stretches and squeezes. It is indeed orbits and goes along through the motions, heats up in the center of the planet, melts the interiors, producing extreme volcanic eruptions and possibly even oceans of magma. Combined with its close proximity to the star, 1 year on this planet is 7.5 years also through our solar system, and each of 7.5 Earth days. Truly hellish temperatures can reach upon the surface. In the future, observations support and presence of such atmospheric temperatures not only would be the smallest exoplanet to have been detected in the atmosphere, but also a crucial step towards understanding the nature of such planets. Folks, to complete this video, detecting atmospherics on small rocky planets is very difficult, as some planets are very small compared to the host stars, and also the intense radiation from their host stars often strips the atmospherics and atmospheres away. These observations are tantalizing, are only from a single transit. That means instrumental noises and other factors prevent us from making any observations, strong claims. Now indeed as well, they will keep the key of confirming the formations of our creativity. Folks, I will come back to you with another short video just like this one about space, the universe, our solar system, objects of interest. Please subscribe to this channel. From Matt Rogers.